means number of peaks in a signal. How many number of peaks are in a signal is called a multiplicity. Before multiplicity, we have studied the inductive effect and anisotropic effect. These two effects are also impact on the chemical shift. Same is the case here, coupling and multiplicity, that also affect on the chemical shift of the proton. So number of peak, if a signal having one peak, then it is called as singlet. Number of one peak is called singlet, and if a signal having two peak, then it will be called as doublet. Signal having three peaks is called as triplet, and any signal having four peak is called quartet. 5 peak in a signal is called quintet. 6 peak in a signal is called sextet, and 7 peaks in a signal is called septet. Sometimes sextet and septet peaks in a signal represented by multiplets. Just write a multiplet. So these are the peaks. Now, how these singlet, doublet and triplet arises from a signals? What are the factors that affect the splitting of a peak? It is the only factor that affect the splitting of peak is the magnetic effect of a neighboring proton. Suppose we have two protons, a proton represented by HA and other proton represented by HB. Both proton, if are in a different environment means they are chemically different, so these both protons affect each other. As we know that each proton behaving in a external magnetic field is like a tiny magnetic field. A tiny magnet just behave a tiny magnet. So there are two possibilities. Suppose we are talking about proton HA, chemical shift of proton of HA we are talking about, and we also discussed proton chemical shift with respect to neighboring proton. How many neighboring protons are? When we talk about chemical shift of HA, it means we will talk about how many neighbors HA have. If HA have only one neighbor, then it will split according to n plus 1 rule. N plus 1 rule says n means how many neighbors. If HA has one neighbor, then 1 plus 1 answer will be 2. So HA will have split it into two peaks in a signals. Now this is a mathematical representation, HA having one neighbor and split into two peaks. In fact, these two peaks arises due to alignment of this neighbor proton HB with magnetic field or against magnetic field. Sometime this proton HB proton, sometimes this HB proton is aligned with magnetic field. Suppose applied magnetic field, external applied magnetic field having the strength represented by this direction, and proton having the same direction as direction of the magnetic field. This is the direction of magnetic field and this is the direction of proton HB. Proton HB is also along the direction of magnetic field. And the second case is direction of this neighbor HB proton with respect to external field, maybe this direction will be opposite, against. This is the direction of the magnetic field and this direction of the HB proton. So direction of the HB proton, two types, against magnetic field and with magnetic field. So because there are two types of alignment, two type of alignment and two type of possibilities of Hb neighbor proton with external magnetic field. Hence two peaks arises in a signal. Because it has two possibilities in direction with respect to external magnetic field. And same is the case for if we study Hb proton, chemical shift of Hb proton with respect to Ha. Same will be the case. This was the case for Ha proton. And if we now talk about the Hb proton, it means we are talking about the chemical shift of Hb proton. We will look into how many neighbors Hb proton have. We have one proton in neighbors for Hb. So for Hb, chemical shift for Hb, how many neighbors? Neighbors are 1. N plus 1 rule says neighbor is 1. So 1 plus 1, answer will be 2. This is mathematically splitting of a peak signals, splitting of signal into 2. So in actually practice, how this Hb proton having a neighbor Ha is aligned with magnetic field. Now we will talk about Ha proton aligned with magnetic field or against magnetic field. With magnetic field representation is just like that, and against magnetic field representation is just like that. So now Ha proton now have two possibilities, against magnetic field direction and with magnetic field direction. So we write signal for this proton is doublet, two peaks. This is the diagrammatic representation. How Hb, red arrow is the direction of the external magnetic field, and this small arrow is the direction of the Hb proton against magnetic field, and this Hb proton with magnetic field. So there are two possibilities, proton having two possibilities with respect to external magnetic field. So two peaks are represented, and two peaks are represented in a doublet. Sometimes doublet is represented in abbreviated form is D, and singlet is abbreviated form is written S, triplet for small t, and hence quartet and quintet represented by Q. And if we write multiplet, represented by small m. This is the case of splitting of a signal, how signals are splitted into peaks. Now if we talk about the splitting of a proton, Ha proton having two neighbors, If we talk about the splitting of Ha proton having two neighbors Hb and Hb, there are two Hb, two neighbors. So what will be the chemical shift, and what will be the signal values, and how this signal will be splitted? Look at the diagram. Because chemical shift of proton, just we have studied, chemical shift of any proton is represented with respect to neighbors protons. How many neighbors? Now we are talking about the Ha, chemical shift of Ha. It means we will talk about the neighbors of Ha. How many neighbors Ha have? They have two neighbors. N plus L rule says, N plus 1 rule says, For we write instead of n 2 because there are two neighbors plus 1, answer will be 3. N plus 1 rule says that Ha proton having 3 peaks, 3 peak represented by triplet. Now these Hb proton which are neighbor to the Ha having the 3 peaks, it is the mathematical representation, but in actual practice, in experiment, these proton having the different directions with respect to external magnetic field. Now we'll look the how these Hb protons are directed with respect to external magnetic field and against the magnetic field, how they behave. A red arrow represents the direction of external magnetic field, and because we know that Ha having both two protons, if two protons are against the magnetic field, external magnetic field direction is upward, and if these two protons having the downward direction, then it will be treated as against magnetic field. This is the one possibility. And other possibility is two proton having the with one and having one against, one proton having the direction with respect to external magnetic field, and other proton having the opposite direction. And second case, one proton having the direction with external field and other proton direction against magnetic field, there are two possibilities here, two possibilities. And in the third case, two proton having the same direction with external magnetic field. So overall we look the pattern of the triplet pattern is just like we write 1 1 2 and 1 1 and 2 and 1. Now what is the 1 to 1? What is 1 to 1 indicates? What 1 to 1 indicates a ratio or pattern or height of the peak. 1 to 1 is the height of the peak. Just it is this peak is represented 1 and central peak is represented by 2 and this peak is represented by 1 to 1 peak. And look the with and against proton direction to the external magnetic field. This is called the ratio of 1, this is called the ratio of 2, and this is called the ratio of 1 to 1 pattern. Because in one we write the one pattern of, this is the one pattern external magnetic field, and this one pattern is against the external magnetic field. And what is the two? There are two different patterns of proton with respect to external magnetic field, two different patterns. And what is this? This is the two protons having one pattern in direction with respect to external field. So overall this is the pattern. 1 to 1 is the pattern of proton direction with respect to external magnetic field, or we can say that 1 to 1 is the ratio of the proton direction with respect to external magnetic field. So this is the height. This 1 to 1 also shows the height of the peak. Triplet of the peaks always show 1 to 1 ratio. Triplet of the peak always show 1 to 1 ratio. Chemical shift of the Ha is impacted by presence of all three Hb proton, each of which can be aligned with. Yes, this is the second possible. This is the second example having the. If we talk about the Ha, when we talk about the Ha, it has 3 proton in neighbors. So n plus 1 rule says n plus 1 rule says we write 3 instead of n plus 1, answer will be 4. So Ha proton must have 4 peaks in a signal, in one signal having 4 peaks. Now there are 4 possibilities of these 3 neighbor Hb proton that have direction with or against external magnetic field. 4 answer means there are 4 possibilities of these proton having direction with magnetic field or against magnetic field. Now look at the diagram having the different possibilities. 4 possibilities are represented in diagram. Now first possibility, because Ha having 3 protons, now 3 arrows are represented downward with respect to external magnetic field, because external magnetic field having the direction upward, and these 3 neighbor proton having the direction downward. So this is a one possibility. And in second possibility, this is one possibility, this is second possibility, this is third possibility, and this is 4 possibilities. So the 4 possibilities we will interpret here. So one possibility is very easy, all 3 proton having opposite direction with magnetic field. And second possibility, in second possibilities there are 3 pattern for a 3 proton having the direction with respect to external magnetic field. There are the 3 pattern. One pattern is that 2 proton having direction downward with respect to external magnetic field, and 1 proton having upward. And second pattern, middle proton having the direction upward, and the peripheral proton having the direction downward. And in the third pattern, first proton having the direction upward as in external field, and remaining 2 proton having downward direction with respect to external field. So in second possibility there are 3 different pattern of proton showing with or against external magnetic field. And in third possibility, these third possibility having the 3 pattern as in second possibilities. These 3 pattern are with and against magnetic field. First proton having downward direction and remaining 2 proton having upward. And second pattern, first proton having upward direction, second proton downward, third proton having upward. Third pattern, 2 proton having upward direction and third proton having downward direction. And the 4 possibilities having 3 proton upward direction as in external magnetic field. So overall we have 4 peaks having different pattern with or against external magnetic field. So if any proton having 3 neighbors, that will have 4 peaks, and 4 peak is represented by quartet. And this is the diagrammatically quartet, how quartet is represented. Quartet pattern is just like central 2 peaks are bigger, taller, having equal height, and peripheral 2 peaks are smaller, having equal height. This is the pattern of quartet. In triplet, what happened in triplet? 3 peaks, 1, second, and third. In triplet, central peak is taller, peripheral 2 peaks are smaller and equal in height. This is the pattern for triplet and quartet. table here, 15.3 table here summarize the multiplicity, indicate number of neighboring protons, how many neighbor proton and how many multiplicity. Multiplicity means how signal is splitted. If any proton having zero neighbor means singlet peak, one peak. Neighboring proton 1 doublet, 2 peak, ratio 1 1. 2 protons having triplet, 1 to 1 ratio. 3 protons having quadret, 1 3 3 1 ratio. 4 proton having quintet means 5 peak, and if 5 proton that will be sextet having 6 peak, and if there is a 6 proton then multiplicity will be septet means 7 peaks. So these are the possibilities of neighboring protons having different multiplicity pattern. Now there are two major factors that determine whether or not splitting occurs. If splitting occurs or not, there are two factors. Two factors determines the multiplicity. What are the two factors? Just look into 2 points. First point, equivalent protons do not split each other. Consider the methylene group in 1,2-dichloroethane. All 4 protons are chemically equivalent and therefore they do not split each other. In order for splitting to occur, neighboring proton must be different than the protons producing the signals. So first point is, we just here look into the structure of organic compound here. Organic compound having 1,2-dichloroethane. In this organic compound, 4 protons are equivalent. Why these are equivalent? Because there is a symmetry. So whenever protons are equivalent, they cannot split one another. Two protons cannot split other 2 protons. Splitting only occurs when there is a different environment. When protons are not chemically equivalent, then splitting will occur. Because these protons are chemically equivalent protons and there is a symmetry in our compound, so these protons will not split the neighbor protons. So equivalent protons, no splitting. So one case is equivalent protons having no splitting. So at what condition splitting occurs? Splitting occurs here. Splitting is observed in these 2 cases. One case geminal proton and other case vicinal proton. Geminal proton, what are the geminal protons? Geminal protons means 2 protons are in same carbon. If 2 protons are in same carbon, then these 2 protons are geminal proton. And if these 2 protons having different environment, geminal protons having different environment, then they will obviously split one another. Same is the case in the vicinal. Vicinal splitting occur. In vicinal splitting is observed. What is vicinals? Vicinals means vicinity. Two carbon which are in vicinity with each other having proton, and these 2 proton having different environment, chemically different environment protons, that will split one another. HA proton will split HB and HB proton will split HA protons. So third possibility is that if 2 protons are far away, splitting is generally not observed. Splitting is not observed when 2 protons are far away. How they are far away from each other? We will count the sigma bond, number of sigma bonds. So we count the number of sigma bonds between 2 protons HA and HB. There are 1 sigma bond here, 2 sigma bond, second sigma bond carbon to carbon, third sigma bond is carbon to carbon, and 4 sigma bond carbon to hydrogen. So they are 4 sigma bond away from each other. this is the largest distance between two protons. So we say that these two protons are generally not split to each other. Distance is far away. Generally speaking, when two protons having the 2 sigma bond distance or 3 sigma bond distance, that will split with each other, but condition is that neighboring protons having different chemical environment. Determine the multiplicity of each signal in the expected proton NMR spectrum of the following compound. So here splitting pattern is to be discussed. This is the organic compound and we have to discuss the splitting pattern. To discuss the splitting pattern, first of all show a proton. So protons are to be shown here in this pattern, and these protons are encircled. So encircled protons means we will able in a position to discuss total number of signal. So total number of signals are one signal for this single proton, second signal for these 2 methyl, third signal for 2 hydrogen, and fourth signal, total 5 signals. In this organic compound, total signal will be 5, and each signal definitely will be split into different peaks. Each signal will be split into different peaks. Now we discuss how these 5 signals are split into different peaks. So look this pattern carefully. First we focus here single proton. This single proton having environment. In proton NMR, when we talk about specifically proton chemical shift value, then we see neighbors proton. This proton, single proton having the 6 proton neighbor. These are the 6 proton in neighbors. So n plus 1 rule says there must be septet. Because 6 proton in neighbor and plus 1 we add, total 7 peak will be obtained for this single proton. And what's about the 6 proton splitting? 6 proton splitting will be doublet. Why doublet? Because these 6 proton having the neighbors 1 proton. So these 6 proton splitting pattern will be with respect to neighbor proton. Neighbor is 1. So n plus 1 rule says when we write 1 plus 1, answer will be 2. So these 6 proton having the doublet. 6 proton having the doublet splitting. And now look at this 2 protons. 2 protons having the neighbors. These 2 protons having the neighbor 2. These are the neighbor. These 2 proton having neighbor 2 proton. This. So this have the triplet. 2 proton having the triplet. Why? Because it has 2 neighbors. N plus 1 rule says it must be triplet. And what about these 2 neighbors? What about these 2 protons? And look the neighboring protons. So these 2 protons also have the neighbors 2 protons. So these 2 protons having the triplet. Now focus on these protons. Count total number of protons. There are 9 protons. And then look the neighbors. Neighbors having no protons. There are no proton in neighbors. So n plus 1 rule says there must be singlet. So these 9 proton having singlet peak. These 9 protons having singlet peak. Because these 9 proton having the structure, I am just drawing here. just trying here 9 proton, CH3, 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 and this carbon is connected to the other carbon. So count number of proton 3, 6 and 9. These 9 proton having neighbors, how many protons? There is proton is missing in this carbon. So proton is absent in this carbon means proton is 0. So proton is 0 means peak will be singlet. So 9 proton having singlet. And what are the group? This is a tertiary butyl group. This is a tertiary butyl group. So keep in mind, tertiary butyl group, if there is a tertiary butyl group, if there is a tertiary butyl group, peak will be singlet. Peak will be singlet for 9 protons. For each of the following compound, determine the multiplicity of each signals in the expected proton NMR. So first of all, we will focus the neighboring proton. This is the methyl. Methyl having neighbors 2 protons. So these 3 proton having 2 neighbor protons means multiplicity of these 3 proton will be triplet, because n+1 rule says neighbor are 2 and 2 will add +1, answer will be triplet. And what about 2 protons multiplicity? These 2 proton having the neighbors 3, then these 2 proton having the multiplicity 4, that means quadret. And what about these 2 protons? These 2 protons having no proton in neighbors, so answer will be singlet. 2 protons having singlet peak. And what about this methyl CH3 having no protons in neighbors, so these 3 protons methyl having no neighbors, that means singlet peak. That means singlet peak. So look into the neighbors, total number of neighbor protons, then add +1, then add +1, so answer will be singlet, doublet, triplet. This is the group of isopropyl group. Isopropyl means 6 protons. Isopropyl group is represented just like that. So these 6 protons having 1 neighbors means there will be doublet for 2, the doublet for these 6 protons, And what about this proton? If we talk about this proton splitting, this proton having the neighbors, how many neighbors? 6 proton. So this proton, single proton having the splitting of 7 peak, septet. So single proton having the septet. And what about the CH2? CH2 having no neighbors, 2 proton singlet, and CH3 having no neighbors, 3 proton singlet. And the structure C and D is the assignment for you. You can solve this problem very easily. Look into the neighbors proton and then add +1, total will be splitting pattern. Coupling constant. What is the coupling constant? Coupling constant means these peaks are coupling constant means these are the peaks. Now measure the distance between peak. What is the distance between 2 peaks, and what is the distance between 2 peaks, and what is the distance between 2 peaks? So what is the average distance between peaks? So when we talk about distance between peaks or average distance between peak, that distance between peak is called as a coupling constant. Coupling constant is represented by J value. Sometimes J value is written. So J value or coupling constant means distance between two peaks. Sometimes we say that spacing between two peaks, spacing, how much spacing or how much distance between two peaks are, that is called a coupling constant. And normally uh, coupling constant does not depend upon the instrumental frequency or external magnetic field, but it has the effect on the overlapping pattern of the peaks. If 60 megahertz spectrometers and 300 megahertz spectrometer are used, so coupling constant will be easily to measure in 300 megahertz instead of 60 megahertz instrument, because in 60 megahertz peaks are overlap with each other and we cannot measure the coupling constant easily. In 300 megahertz instrument, if instrument having 300 megahertz power magnetic field, that peaks are very easy to interpret J value, because these peaks will not overlap with each other. So in a research work, generally 300 to 500 megahertz instruments 300 megahertz or 500 megahertz instrument strength is used in a research work to interpret the coupling constant. If in a research work 60 megahertz is used, that will be not facilitate and not helpful for the interpreting coupling constant. So it is not recommended in the research work. In a research work, 300 and 500 megahertz instrument magnetic field strength is recommended for interpreting coupling constant, because in 300 and 500 megahertz peaks are not overlapped with each other, and coupling constant we easily measure the coupling constant. In this paragraph just I have mentioned the 60 megahertz and 300 and 500. So I think coupling splitting pattern is today is sufficient for uh, coupling constant and splitting pattern multiplicity. Any question? Sorry. Okay. Okay. Thank you.